so since we learned how to solve 3 by 3 linear systems of equations, let's apply it to some word problems now. So here we have a word problem as such. A triangle has one angle that is twice the size of the other angle. The biggest angle is twice the sum of the other two angles. Find the three angles. So I know that's worded a little bit confusing or whatever, but we're going to try to simplify things down. So here I just drew a triangle just to get a feel of what they're talking about. I labeled the angles with the variables as x, y, and z, and then I declared my variables before I started. So I named them accordingly to what the word problem had stated, so I could use that to my benefit. So I just said x is one angle because it said up here that a triangle has one angle, right? So I just named that one angle x. Then it said that is twice the size of the other angle, so I named y is the other angle. Then finally it said the biggest angle, so I just called the biggest angle z. So that's how I went about setting up my variables and naming them. So now I have to come up with three equations because there's three angles in a triangle, and yeah, so with that I'm going to have to come up with three equations. So let's see, one angle is twice the size of the other angle. Well, x is my one angle that we talked about. We denoted that in red. It's saying that is twice the other angle, and the other angle we named y. So there's one of our equations, right? Then it says the biggest angle is, so our biggest angle we declared as z, and that is twice the sum of the other two. Well, the only other two angles remaining is x and y. So just based off the wording, these are the two equations that I came up with. But I still don't have three. So to come up with this third equation, you just need to know a general fact about the triangles, the angles in a triangle. So you just need to know beforehand that the angles of a triangle add up to 180. It doesn't matter if it's a right triangle or any type. It just adds up to 180. So that's just the fact you have to know prior going into this problem. So our third equation is going to be x plus y plus z is equal to 180, because I know all of those angles will add up to 180. So after we have come up with the three equations, we can go ahead and apply any method we'd like to solve for those three angles. Okay, so going about solving this now, notice that if you watch this video from the beginning, it's like the first case, the easiest case, where they give you what one variable is already equal to, because we have what x is equal to here already. So I'm going to take this x and plug it into an equation that has two other variables, not one that has all three yet. So I'm going to take this x and plug it into this x here, right? This equation x is going to get replaced with this little x here. So doing that, I get z equals 2, and instead of x, I'm going to write 2y plus y. Right, so this was x before, and I replaced it. So then you get z is equal to 2, and then 2y plus y is 3y. And then 2 times 3 is 6, so you get 6y. Right? So now I know that x is equal to 2y and z is equal to 6y. So it's pretty much like I've solved for two variables already. I know what x is equal to 2y, and z is equal to 6y. So I could plug both of those into an equation that has three variables like this one. And notice what happens when I do that. X is 2y and z is 6y, and there's already a y here. So I'm getting everything in terms of y. I'm just working with y's, because we only know how to solve variables, we only know how to solve equations that have one variables in them when we isolate them. So let's go ahead and substitute this x equals 2y into this x to get 2y. Leave the y alone. Z is also 6y, and that equals 180. So then 2y plus y is 3y. 3 plus 6 is 9y. Okay, divide the 9 over. You get your first variable, which is y. So you get y is equal to 9 goes into 18 twice, and there's the extra 0, so 20. So we get that y is equal to 20 degrees. Okay, since we know what y is equal to, y is equal to 20, we could sub that into here to directly get x, right? So we're going to get x is equal to 2, and instead of y, I'm going to put 20 because we just found that out. And 2 times 2 is 4, with the extra 0 will be 40, so we know that x equals 40 now. Y equals 20. We just need to find the last angle now. Our last angle was z. It has a relationship with y, and I know what y is equal to, it's 20. So going off this, z is equal to 6, y is 20. So then z is equal to 2 times 6 is 12, and the extra 0 is 120. So then we get z is equal to 120. Okay, so that would be our answers. The angles would be 40, 20, and 120, and we labeled them so x is that, y is that, and z is that. On all the other problems that I did with you guys, I never plugged our variables into the equation to see if it was correct. But for this one, it might be worth our while to do so to see if we get 180, right? Because that's what all the angles should add up to. So let's just really quickly do that. 40 plus 20 plus 120. We want to see if this will give us 180. Because if we still want to see if that's equal to 180. So 60 plus 120 is 180. So that's a little quick way to see if you could, if you did this problem correctly. So again, it wasn't that bad. You just had to know that the angles in a triangle add up to 180, and that's how you would approach a problem like this. Okay, so continuing with these applications related to 3x3 linear systems of equations, here's another problem that you might come across. So it says 1,000 tickets were sold at a play which generated $3,800 in revenue. The prices for the tickets were $3 for children, $4 for students, and $5 for adults. Then it says there were 100 fewer student tickets sold than adult tickets. So it wants us to find the number of each ticket sold. So before I like to start these problems, I like to declare my variables or name them so it's easier for me to work with them, like referring to them. So I labeled X for the number of children tickets sold. I called Y the number of student tickets sold, and I labeled Z the number of adult tickets sold. Okay, so based off that, I'm going to go ahead and try to come up with my 3 equations because we have 3 variables here. So it says 1,000 tickets were sold at a play. Now based off that, I could just form an equation off that already, because these are the number of tickets sold, and it says altogether there was 1,000 tickets sold from all of these guys put together. So I know that X plus Y plus Z is equal to 1,000 because 1,000 tickets were sold, and I declared these to be the number of tickets sold for each of my categories, which were children, students, and adults. Then it says they generated $3,800 in revenue. So this is how much revenue they got when they did $3, right? It was $3 for the children, but we don't know how many of those tickets they sold. Similarly, it was $4 for the students, but we don't know how many tickets they sold, and it was $5, I believe, for the adults. So when you multiply the number of tickets they sold by how much it costs, you would get the revenue. So here are my two equations. Now the last one's going to come from that funky sentence right here, where it says there were 100 fewer student tickets sold than adult tickets. So since we're talking about student tickets, and that's why, I'm going to go ahead and say y equals, right? So the student tickets, there was 100 fewer student tickets sold than adult tickets. So if I take the adult tickets, which I'm letting represent z, and I take 100 away from them, that would translate into my number of tickets for the student, because they're saying there's 100 fewer students tickets sold than adult. So if I took 100 away from the adults, then I would be equivalent to them. That last one is kind of hard to, because when I've tutored people, I've seen this last one's kind of wordy, and you could phrase this. You know, this isn't the only equation you could come up with that last sentence. So just experiment with it, try other problems, but you know, when looking at it, this is how I would come up with an equation based off that sentence. So now that we have a 3x3, let's see which category it falls into. See, this equation here only has y and z in it, and if you watch the earlier videos, when we only have two variables here, and with these other two, they have three, we want to eliminate the one that this guy doesn't have. So there's no x variable here. So from these two equations, I want to eliminate the x variable. So I only have y's and z's left, and then I could just eliminate from there. So I have to eliminate the x from these two equations here. And it looks like the easiest way to do that would be to multiply this by a -3. So doing that, I get -3x minus 3y minus 3z equals -3,000. And the bottom I'm just going to leave alone. 3x plus 4y plus 5z equals 3,800. And remember, we're always adding these equations, so the x's cancel. You get y plus 2z is equal to 800. And I'm going to put a little star by that guy. If you watch my previous videos, that's just what I do, because when you're doing this on paper, you're dealing with a lot of equations, and you want to see which ones you should put your focus on. This is definitely an equation we want to put our focus on, because we got it down to two variables. Now we could put it side by side with this equation and work with it, because they both have y and z in them, and we could eliminate that way. Okay, so just picking up, here I have my two star equations because they both have two variables that are common that I could eliminate now. But since, you know, I could use a substitution here because y is equal to that. But since we're in this whole elimination theme, let's just go with elimination. So there's a y and a z on this side. There's a y here, so I need a z on that side. So I'm going to subtract the z over. So doing so, I get y minus z equals -100. This equation I'm just going to write on the bottom, which is y plus 2z equals 800. Okay? This equation is really the same thing as that equation. I just moved stuff around, so I'm going to erase these for now. Okay, over here, it looks like if I multiply this top guy by a 2, because once you're with two variables, you could eliminate whichever one you want. So I'm going to eliminate the z, so if I multiplied it by a 2, that's what would work out. So then I would get 2y minus 2z equals -200. The bottom would just stay the same as y plus 2z equals 800. Remember, we always add, so the z's cancel. We get 3y equals 600. Dividing by a 3, we get y equals 200. Okay, so we got our first variable, and once you get your first variable, it's game over. It's just back substituting into all the other equations we had to get the other variables. Okay, so y equals 200. Go with this one. So y is 200, so we get 200 plus 2z equals just 800. Solving for z, you got to subtract the 200 first. So then you get 2z is equal to 600. Dividing the 2 over, you get that z is equal to 300. So now we have two of our variables solved for, when you have two of your variables solved for, you jump to an equation that has three variables. So we have to jump to one of these. It looks like this one would be better because there's no coefficients in front of them. So let's go with this. We have z and y. We don't know x. So I'm not going to touch the x. Y is 200. Z is 300. And that equals 1,000. So x, 200, 300, 500. Subtract the 500. To get that x equals 500, because 1,000 minus 500 is 500. Okay, so x, y, and z, because this is for the children, students, and adults, right? So we got that the children was 500, we got that the students were 200, and we got that the adults, I did not see that. Okay, but those are the number of tickets for each one sold, right? Because we labeled them and you have to answer it accordingly to what they asked. So 500 is a number of children tickets sold, 200 is a number of student tickets sold, and 300 is the number of adult tickets sold. And you can plug these back into the equations to see if they add up to 1,000. So let's see, 200 plus 300 is 500, and then 500 plus 500 is 1,000. So so that's how you'd approach a problem like this.